right, so here today, guys, we are going to talk about notes 15.4, which is your I can statement is I can graph an exponential function in the form of a times b raised to the exponent of x, which I am assuming now that you can do, okay? Because we've already done that in a couple lessons, right? So I think you're probably in good shape. Where we're going to spend our time is on the second concept, which is I can identify the a, the b, the y-intercept, and the end behavior. This is the new part right here, the end behavior of an exponential function. So I'm going to show you, first of all, I'm going to break it down in parts. The first part I'm going to talk to you is about these three things, which they're not going to be that bad because we've done those before. And then we'll spend most of our time on the end behavior. Okay, so first the vocab. Let's talk about that. So when we talk about our vocab, the y-intercept of the exponential function, well, it's the same as a regular straight linear line. It is where it crosses the y-axis at. So I just want you to sketch exponential function in here. So start on the left side and go along the x-axis, but I'm going to say this, and this is really, really important. Do not go below the x-axis when you sketch this graph. Don't go below the x-axis, because that's what an exponential function is. If it starts out above the x-axis, it's never, ever, ever going to go below the x-axis. So sketch that out for me. Now, as you sketch it, we're going to identify the y-intercept. Well, if you didn't put your y-intercept right there at 1, don't worry about it. Just fudge it, get it close to it, whatever, it's okay. So my y-intercept is 0, 1. So the y-intercept we know is where it crosses the y-axis at. You guys already know that from previous lessons. So let's talk a little bit about what the domain is. Anybody remember the word domain and what it represents?
The X value.
Yeah, good. It's the x values. So write this down right here. It represents the x values. Okay, so now what is different about this domain is that there are two domains. There's a positive domain and a negative domain. A positive x value and a negative x value. Here's what I'm talking about. This x value, do you agree with me, keeps going on and on forever and ever because of the arrows?
Yes.
So that means 1, 2, 3, 4, 5, 6, so on and on. So what would the domain be of the positive end? Well, what is a number that, what do we say when something's going on forever? We say it's going on infinite. Yep, so the domain is infinite on the x value, the positive x value. So now this is where kids have a little bit of trouble. Look at the x value that's negative over here. It is actually going on and on forever too, going up, up, up. Now it's not actually going straight up, and I kind of exaggerated it right there, making it go further and further away from 0. So it actually is going on and on forever, but it's in the negative direction. So it would be a negative infinite. Okay, so how do we write that? I want you to write it over here, and I'm going to make you write it a couple times today. We would write it like this, as a compound inequality. It is a negative infinite, which an infinite symbol is just an 8 to the side.
I can't draw
Is, that's all right, just draw an 8 to the side, just do the best you can. Is less than x, which is less than infinite. So here's the deal, if you look at it, it's saying that the domain is going on and on forever in the positive direction, and the domain is going on and on forever in the negative direction. Negative infinite, positive infinite, that's what the x value represents, okay? So this is where it gets a little tricky. What is the range? Well, we know that the range, if you know the x value is the domain, you know the range is the y value. So write that in, it's the y values. And this is where really the meat is. And we're going to talk a little bit more about it, so we're not going to spend a ton of time at this moment on it. But what I want you to notice is, for the positive x value, if the positive x value keeps going on and on forever, what's happening to that y value? It's going down closer to 0. It's actually getting closer to 0. And that's what we're going to talk about. That's the end behavior. Over here in the negative direction, as the x value goes on and on forever, hey, what's happening to the y value? It's going further and further from 0, so it's going on infinite. So that is what the end behavior actually represents, is basically what is happening to the y value. So I want you to kind of write this word for word, so I'm going to write it word for word too. So it says what the end behavior is, what is the y value of the graph doing as the x, or as the domain increases into positive infinite and negative infinite. So and as you're writing that down, go ahead and finish it, but the end behavior is what's happening to the y value. Is the y value getting closer to 0, or is the y value going away from 0 into infinite? That's what our job is today, to find that end value, okay? Before we do the first part of your homework assignment, again, we're going to break it down into the easy part, then I'm going to kind of tackle the end behavior. So you're going to have to, on your homework, identify the a, the b, and the y-intercept given a table and given an equation, but it's not too bad. So right here, I already told you this earlier today. Remember that the a also represents the what? The y-intercept. What is the y-intercept? 0, write it as a coordinate pair. 0, 2 is the y-intercept. But the a represents the y value. So can you write that over here? The a equals the y value of the y-intercept. Okay, so the a represents the y value of the y-intercept. So right here, our a represents 2. We already know how to find the ratio, the b, right? The b, write this down, equals the ratio. So how do we find the ratio? We divide our y2 divided by our y1, which we can do this really fast. 2 divided by 5. What is 2 divided by 5? 0.4. So we can actually write an equation. Do you guys see that now? It's kind of cool. You can write an equation given a table. Okay, you don't even have to graph it. So right here, let's write our equation. It is what? F of x equals, what's my a? 2. What's my b? 0.4. Yep, 0.4 raised to the exponent of x. Done. So there's our equation. Now, the second part of this is even easier. Identify the a, the b, and the y-intercept, because it's all given when you have an equation, right? So ready? Tell me what my a is.
-3.
B and y-intercept.
0,
That's it. Okay, so now that's the easy part. On your homework, however, just so you know, you have to do all of this. You have to write your a, your b, your y-intercept, as well as your end behavior. Okay, so now let's talk about the end behavior, because that's kind of the hard part, okay? So if you look right here, I'm going to move this out. The end behavior, we are going to identify it according to if the the exponential function is increasing with a positive. So I want you to look at this because I want to show you something. So if it's increasing with it's a positive exponential function, does it ever go below the x-axis? No, it gets closer and closer to 0. Watch this. It gets closer and closer to 0, but it will never, ever, ever cross that x-axis. So our range is always going to be y is greater than 0. Do you guys understand that? So the y values will never, ever go down here, ever, because it's a positive exponential. Sort of with me? Just sort of, right? Just hang in there for a few minutes. You'll get it. It'll become clear. What's our domain? It's the same every time. What is our negative doing? What is our negative domain or a negative x value? Negative, yep, negative infinite. Write it down. Less than x, which is less than, what's our positive domain doing? Infinite. Every single time, your domain is doing the same thing. It's negative infinite less than x, which is less than infinite. What is not the same is your exponential, which means your range. We have to pay attention to that, okay? If it's positive, it's going above the x-axis, and if it's negative, it'll be below. So I wrote this out in the box to tell you exactly how to find the end behavior. So here's how you find the end behavior. You say to yourself, as the positive x value moves towards, so ready, here's my positive x value, and where is it moving towards? We know it's moving towards what? Infinite, so write infinite in there. What is the y value doing? Is it moving towards 0, 0? Is it moving towards here, or is it moving towards infinite? Yep, so that's all you write. So y value is moving towards infinite. So what we're doing is we're identifying what's happening to the y value, guys, according to the exponential function. Okay, now let's look at the negative end. What's happening as the negative end is going? As the negative x value moves towards what?
Negative.
Negative infinite, because that's the same every single time. Then the y value is moving towards what? Now look up here. The y value, isn't it getting less and less and less? So it's going towards what? 0. Well, nope, it's going towards 0. It's going towards the x-axis. See, these numbers right here are your y values, and it's getting closer and closer to 0. Will it ever hit 0? No, because it will never, ever, ever cross below 0. It's always going to be greater than 0. Okay? So now here's the part that you have to write on your homework, and you're going to say, well, what do I have to write down? This is what you write. So we write the end behavior like this. The positive x, as what happens to the positive x? As it moves towards, as it moves towards infinity, comma, then the y value does what? It moves towards what? Infinity with this quadrant, or with this exponential function. There are 4 different types of exponential functions. So you have to pay attention to what's happening to your y value. Okay, what about the negative end of the x, or value? So the negative x, as it moves towards what? Negative infinity, which is this guy right here, then the y moves towards what? 0. Do you guys see it? This is what I expect you to write down on your paper. And don't worry, when we do these last 3 more, you're going to get a lot better. I know this is kind of all, like it's all fresh, it's all new. Okay? Flip it over to the other side. And now this is a different type of exponential function. But what I want you to notice is it's still what? Why is it positive?
Because the x is...
Yeah, because it's above the x-axis. Which means my y value is always going to be greater than 0. Are you guys with me on that? Okay, now, what do I write for my domain? The same thing every time. My negative x value is always going to be negative infinite, less than x, which is less than infinite. So my x is always going to be between infinite and negative infinite. But now you have to pay attention as the positive x value moves towards what? Well, my positive x value is moving towards what? Infinite. Look at it. Here's my positive x value. What is my y value doing?
Moving towards 0.
Yeah, it's moving towards 0. These numbers right here, it's getting closer and closer to 0. Look at your negative x value. As it moves towards negative infinite, my y value is moving towards what? Well, look, where's it going? Is it going towards 0, 0?
Infinite.
Yeah, it's going up and up and up, which means infinite. So it's going towards infinite. And then how do we write it? Write positive x goes towards infinite. What's happening to my y value? My y goes towards what? 0. Yep. As my negative x goes towards negative infinite, my y value goes towards what? Infinite. So this part right here is what you say in your head. This is what you write down on paper. Okay, is that making a little more sense? Okay, well keep working with me, okay? All right, ready? How about this third one? It says identify the end behavior of an increasing negative exponential function. It's a negative exponential function. What do you know about it?
It's below the x-axis.
Yep, it's below the x-axis, so that's why y is less than 0. Are you guys following me on that? Okay, write it down. What's your domain? Negative, infinite, less than x, which is less than infinite. Okay, so as the positive x value moves towards what? What do we write there?
0.
No, the x value.
Infinite.
Yeah, remember x value first. So x value moves towards infinite. Here it is. The y value is moving towards what? 0. See how it's getting closer to the x-axis? But it's never going to cross it. But it's getting close. So if it's getting close to the x-axis, it's moving towards 0. Okay, as the negative x value moves towards what? Negative infinite. The y value is moving where? Yeah, negative. Nice job. Way to catch that. It is infinite, but isn't it below the x-axis? So isn't it the negative y values? So we would write negative infinite. That's a little tricky. Okay? All right, let's write our answer then. So what would we write? What's our end behavior? Well, as the positive x increases towards infinite, the y value goes towards what? 0. As the negative x value goes towards negative infinite, the y value goes towards negative infinite. All right, last one right here, and then I'll give you a little shortcut that might help you understand a little bit more. So this is the last type of exponential function right here. So first of all, it's decreasing again, and it's a negative. Sorry, I meant to say negative is the part I really want you to get. If it's negative, where's it at? Above or below? Below. So that's why y is less than 0. Go ahead and write your domain in, which is the negative x less than x, which is less than infinite. Negative infinite less than x less than infinite. Okay, this is our positive end right here. This is our positive x. As our positive x moves towards infinite, what's happening to our y value? Is it getting closer to 0 or away from 0? So what do we write?
Negative.
Nice job. Way to remember that's a negative infinite because it's going down. Get it? Okay, ready? Now let's look at our negative end over here, a negative exponent, or a negative x. So this is, as our negative x value moves towards negative infinite, what's happening to our y value?
0.
Yeah, it's getting closer towards 0. And again, that's what you're saying that in your head, you're figuring it out, you're talking it through. But when you write it on paper and pencil, this is your answer. The positive x moves towards infinite, and the y value moves towards what? Negative infinite. As the negative x moves towards negative infinite, comma, the y value moves towards 0. Now listen, there's 4 types of graphs. Okay, hold on one sec. There's 4 types of graphs. So what you have to do is you have to look at the graph and you see what the behavior is. But we'll do a couple examples, so a couple homework problems that will help you to understand what the expectation is. Go ahead.
I'm not understanding where it's moving to 0.
So here's your shortcut. See if this makes sense. I wrote this down and I think it might help, okay? So here's your shortcut. This is what you're going to ask yourself right here. So I'm going to cover that up right there. So you ask yourself, is the graph moving towards the x-axis? So let's just look at this example, this last one. And let's look at this part right here. Is the negative graph, is this negative part moving towards the x-axis? What's your answer? Yes. If the answer is yes, then the behavior is moving towards 0. Then the y value is moving towards 0. Okay? Now let's look at the other end of that. Now let's look at this one. If the graph is moving away from the x-axis, see, this is your x-axis. Do you see it moving away? So if it's moving away from the x-axis, then what's happening? It's going to be infinite. Well, and here's the thing. I don't want you to necessarily write negative infinite. I just want you to write infinite because it works both ways, both positive and negative. It just so happens that this one is negative. Okay? So this might help you as a little shortcut. I don't know. But I'm going to show you what the expectation is for your homework. So if you turn to your next set of notes right here, guys, this is an example of what you have to do on your homework. And we'll do 2 more problems, and hopefully that will help you to feel a little bit better about it. So these are actual homework problems, number 15 and 16. I pulled them right out of your homework, okay? So it says, first of all, now we're putting it all together. This is what you have to do for your homework. You have to state the a, the b, and the y-intercept. Then you have to graph the function and describe the end behavior. Okay, so I'm going to first say, let's do this, the a, the b, and the y-intercept. And I have a little box right down here. So everybody tell me what the a is. Yep, tell me what the b is. And tell me what the y-intercept is.
0, 9.
Yeah. Now, the end behavior is what we have to figure out. How do we do that? We have to graph it. I'm telling you, for every problems 9 through 18, use -1, 0, 1, and 2 as your x values. Only those 4 is what you have to use. Okay? Just those 4. So you can plug this into your calculator. 9 times 3 raised to the exponent of -1. Somebody figure that out and tell me what you get. It is 3. Yep, because 3 to the -1 goes on the bottom, right? So that's 9 divided by 3 is 3. Okay, we could do this one in our head. Anything to the 0 power is 1. 1 times 9 is 9. You should be able to kind of figure it out a little bit. I don't know if you guys see this, but your ratio is 3. So really it's being multiplied by 3, right? So 9 times 3 is 27. And 27 times 3 is 81. Now you can plug all those in. I just don't want to waste time right now. I want to make sure you guys get this, okay? So let's graph it. Ready? So go over to -1 and go up to 3. And again, you got to estimate because this is going up by 15s. So it's going to be right about right there. Go over to 0, go 0, and go up to 9. So it's going to be slightly above, right? It might be a little high, but I'm going to let it go. Okay, go over to 1 and go up to 27. Go over to 2 and go up to 81. I'm going to say it's right there. Now, I know that I told you what numbers to use, but the domain is not given to you. So what do we have to do? Yeah, we got to connect our lines. Now listen, I want you to make a nice smooth curve right here. A nice smooth curve through here. Arrows off the end. But will this ever go below the x-axis? Do not let it go below the x-axis. Okay? So now let's talk about the end behavior. Now I said this last hour to my other class. If I were doing my end behavior and if I were you, the first thing I would write down is positive x goes to what? Infinite. I heard it. And negative x goes to what? Negative infinite. Then the y value goes to, let's answer the question. This is given to you. This is all given to you. So ready? As the x value, this is your x value positive. This is your positive x value. Is this line right here getting closer to the x-axis? Or is it going away from the x-axis? So that represents infinite. Yep, so that represents infinite. Making sense? Okay, now this is our negative x. This is our negative x. And as it's getting closer to negative infinite, it is getting closer to what number? 0. So y is increasing to 0. But it will never go below 0. Okay? Are you guys with me? All right, last one right here. Make me a little XY table. And -1, 0, 1, and 2. And real quick, say it out loud. What's my A? -5. What's my B? And what's my y-intercept? You got it. Okay, now, actually with these you can actually do them in your head too, but that's okay if you don't want to. Can somebody do this math real quick? -5, parentheses, 2 raised to the -1. -2.5 is correct. All right, this one you should be able to do in your head because 2 raised to the 0 power is 1. 1 times -5 is -5.
It's just going down by 2.5.
Yeah. Well, okay. So ready? 2 to the power of 1 is 2 times -5 is -10. And it's basically being multiplied right here by our ratio. What's our ratio? 2. So what's our next answer? -20. All right, right side and graph it. So go over to -1. Look, here's -2. This messed me up last hour as well. So if that's -2, -1 is right here, just for the record. So go over to -1 and go down 2.5. So again, estimate. Over 0 and down 5, we're estimating. Over 1 and down 10, that's 14, so 10 is probably right about there. And over 2 and down 20, which is probably right about there. I need a nice smooth graph, so make it smooth. Okay, there it is. All right, so ready, our end behavior. Again, what would I write first? I'd go ahead and write all this stuff out real quick. Positive x is increasing to infinite. Negative x is increasing to negative infinite. And y is doing something, but I don't know yet. Let's see what my y is doing. Okay, are you guys with me? Okay, so last bit right here. So what is our y doing on this positive end over here on the x? Is it getting towards 0 or going away. So it's infinite. And it's negative infinite, yep. Why is it negative infinite? Because it's below the x-axis, yep. Okay, ready? And the negative end over here. My negative x is getting infinite, and it's getting closer to what? 0. Closer to 0. So y is getting closer or increasing towards 0. Okay?